Hello student, today we are going to study Verilog practical for the code conversion. So initially we are going to convert binary code into the gray code. You must know what is meant by binary and what is meant by gray, okay, and how does the conversion take place. So for this purpose we are going to see this conversion over here. This is the binary code which is represented by the bits B3, B2, B1, B0. These are the four binary code. This binary code can be converted into the gray code in this manner. You know that the MSB bit of binary is exactly equal to the MSB bit of gray. That means hence B3 is equal to G3. The conversion takes place like this. The MSB bit can be written as it is, okay. That means B3 is equal to G3, hence G3 is nothing but the B3. Now this bit, most significant bit of binary code, MSB bit of binary code, is added with the next bit, and then you get second gray code. That means B3 is XORed with B2, and by XORing these two you get the second code of gray, that is G2. Similarly, B2 bit is XORed with B1, and then you obtain the second bit, that is third bit, that is what, G1, okay, and hence B1 can be XORed with B0 to obtain the G0. So in this way binary to gray conversion takes place. The same conversion can be shown by using this diagram. So see here in this diagram, for our convenience we are selecting the 4-bit binary code as A, B, C, D, and here you have 4 gray codes G4, G3, G2, G1. As I told you, the MSB bit for the both remains same, hence the MSB of binary is equal to MSB of gray, hence only the line is drawn over here because both are the same. G3 can be obtained by XORing 2 bits of binary. That means when A is XORed with B, then you obtain G3. Similarly, when B is XORed with C, you obtain G2. When C is XORed with D, you obtain G1. So in this way the binary conversion takes place. See here, these are the code for binary to gray. So according to this circuit diagram, the codes are written over here. This is what this process is, binary to gray conversion, is it? Hence the module name we are taken over here is B2G, okay. This is the module name. In bracket we have to write the input and output. So B means binary data is the input, gray G means gray code are the output, hence B and G as written over here. As I told you this, we have to initialize 4-bit input, binary input like this. Input in bracket 3 towards 0 means there are 4 binary bits B0, B1, B2, B3. They can be initialized by using this instruction, input in bracket 3 to 0 B. Similarly, there are 4 outputs, again from 3 to 0. G stands for gray code is the output, hence output can be initialized by using the instruction output B, G3, G2, G1, G0 like this, okay. Now we have to assign the output with our input. That means what is the status of output? Means see here, G4 is equal to first MSB bit, hence G3, that is MSB gray code, can be assigned by using the MSB bit of binary, that is G3 is equal to what? B3. How you obtain the next code, that is G2, okay? It can be obtained by using this instruction. That means the second binary code can be obtained by XORing these 2 bits, okay. That's why G2 is equal to what? B3 XORed with B2. Similarly, you have to assign each gray output with XORing the inputs and AND module. This is the Verilog code that we are going to see. We are going to run by using ISE Verilog simulator. So this is the Xilinx ISE. We are using Xilinx code. So how to use this, you just see carefully. Okay, Xilinx ISE window can be look like this. This is the window for this. So initially you have to click on file, then new project. Okay, you have to enter the project name over here. Suppose E, whatever you want you can give. IP, I given the name IP over here. Okay, then click on next. When you click on the next button, you can see the properties of your Xilinx software. Okay, so see the product category all. It belongs to the family Spartan 3. The device used in this is XC3S400, that is IC name you may call. This is the package PQ208. The speed is of -4. You have to select these properties over here. Okay, the synthesis tool that we are going to use in this software is XST VHDL / Verilog. It belongs to both the languages. The simulator is ISE simulator. Okay, and the preferred language that we are going to implement over here is a Verilog. Okay, so just click on next, again next, and then finish. So when you click on finish, this window is appear. See here, this is your source window, this one, and this is your process window. Okay, so whatever file you are going to make over here, that can be labeled in this area. Okay, and this is the process. Whatever you going to do the process, you have to do from this space. Okay, so this is process window and this is your source window. Okay, now see, this is our project name IP. Okay, and this is your device name, that is XC3S400. This is the package, and okay, and this is -4 is what the speed. Okay, so we just choose all these device property. Okay, now you just right click on this, click on new source. Okay, then click on Verilog module. Then give the file name over here. You may write any file name. I am writing IP. Okay, then click, see, this is the location of the your project. It is located in the D drive Xilinx folder. Okay, then click on next. Okay, again click on next and finish. Okay, when you finished your process, then this window is pop up. Just write down the code. This is your editing window. Okay, these are the what comments. You have to write your code in these two instructions, that is module IP and end module. Here you have, this is your editing area. You can edit or you can write your instruction in this area. Now I have the code copied with me, so I am just going to click or paste those code over here. So these are the code. Okay, what is our module name? That is IP. As I copied this from the previous project, that's why the name is here. Now I have to replace this name with the IP. So I am just copy the IP project. I am going to paste that here. Okay, and you just rub this because I have copied the code. Okay, now see, end modules are there, two end modules are there, so I am going to delete one. So this is your code. Okay, I explain this, I just explain this code. Okay, now you just save this code. Okay, after saving this code, you click on, you just go to the source window, click on your project. Okay, then select synthesis implementation. Three types are there: synthesis, behavioral, post root. So I am going to choose synthesis because we have to synthesize this code. Okay, now in the process window, you just go to this sign, that is synthesize XST. Okay, expand this, check syntax. When you click on check syntax, your syntax, that means your codes are checked in. If there is any syntax error, that can be recorded. So you just click on check syntax. Now see, the checking process is there. See this window. Okay, in this window you get the recorded message. Okay, so what is the message? Process check syntax completed successfully, means there is no any kind of syntax error in your program. Okay, so once it happens, you have to go to in source window, click on this device, right click on this device, new source, then you just click on test bench waveform. Okay, give the name for this. You just give the name apart from your project and previous file. So I'm going to write IP1 over here. Okay, then you just click on next. See, you just observe this is your IP project, so click on next, then finish. Once you finish this, okay, the waveforms are appear over here. This is the waveform. See, what is the program, what is our aim? We have to convert binary code into the gray code. That means we have the binary input. So you just click on this plus, that means expand this. So these are the 4 binary codes, B0, B1, B2, B3, that we are used in our program. See this one, B1, then B2, B3, B0, B1, B2, B3. Okay, now see, you have to give the inputs from this side. See, these are the inputs. You just expand this gray code. This is the input, this is the output. Now we have to write, we have written the code to convert this binary code into the gray form. Okay, now I am going to give the input status here. When I click on this blue color side, okay, so the state is changed from 0 to 1. Now your, see, initially it is 0. When I click here, the state is changed, input state is changed, and that is 1000. That means I am giving the code 100, binary code 100 to this module. Now this module converts this 100 into the gray form. So for this conversion, initially you have to save this test bench waveform. Okay, after saving this, you just go to the source window, click on the second option, that is behavioral simulation, and you have to select this test bench waveform, this one. Okay, so I just click on this bench waveform, then you just move towards the process window, click on process. See, this is the Xilinx IC simulator. Now we have to simulate our code, hence you just click on this plus sign, again click on this plus sign. Okay, see, you have to generate self-checking. That means these inputs are checked internally. So I'm just click on self generate check. Okay, so the process is going on. We have to wait till the process is end. Okay, it is going on. See here, the messages pop up. That is what, only one instant of, okay, that means we have to click on yes. When you click here, the test bench waveform will disappear. Now again you go to the source window, click on the test bench waveform. Here you have the behavioral simulation, then move to process window and click on simulate behavior. That means you are going to simulate, and you can generate the output by clicking on this tab. So I just click here. See, the process is going on. Again the process is going on. You have to wait till the process is end. This is your simulation. This is, see the window, simulation. This is your simulation. So initially I am going to show you which input you have given previously. So what we are given previously, that is